So here we're just going to tackle a few sort of miscellaneous trigonometry based problems, just where we're working in radians. So it's all stuff that we've done before with degrees, so hopefully that side of it shouldn't be too scary. However, we've just got to be confident with radian measure and being able to convert back to those degrees. So for example, we might start off with, say, we want to work out what the sine of pi is equal to. Well, what is pi? How many degrees is pi? Well, if we remember that pi, well, we know that 2 pi is 360 degrees. Remember, that's sort of the golden rule that we want to remember. And that's what we proved when we were kind of looking at working out what radian measure actually was. But also, another handy one to kind of know is just if you were to cut both sides of that equation in half. So you're just looking at half a circle now. So pi is actually 180 degrees. So that's also a handy one to remember. And you'll see us use both of those quite a lot throughout this video. So this is just the same as us working out what the sine of 180 degrees is, and we know that that is equal to 0. Secondly, we'll have a crack at maybe working out what the cosine of pi on 2 is. Well, we know what pi is. We know that pi is 180 degrees. That's one that we've got written down there. So pi on 2, that would have to be 90 degrees. And again, we see that that would also be equal to 0. Thirdly, I've got 6 of these questions. Thirdly, we will have a go at maybe what tan of pi on 4 is. So once again, we know that pi is equal to 180 degrees. So pi on 4, I need to break that 180 degrees down into 4 equal pieces. So I'm going to be looking at 45 degrees in that case. And the tan of 45 degrees is just equal to 1. Okay, that's an exact value that we need to be able to remember. Fourthly, maybe we're looking for what the sine of 5 pi out of 6 is equal to. So let's have a look at what pi on 6 would be. So what would pi on 6 be? Well, I know that pi is equal to 180 degrees. So if I divide that into 6 equal pieces, I would be dealing with 30 degrees. Now, how many of those pi on 6 portions do I have? I've got 5 of them. So 5 lots of 30, I'm looking to calculate the sine of 150 degrees. Okay, now I know that is the same as the sine of 30 degrees, because if we look into our unit circle here, okay, sine of 150 degrees is that angle there, sine of 30 degrees is this angle here, and they're going to check in to the same spot in the positive side of that y-axis. So this one here, sine of 30 degrees is equal to a half. We'll do another one here, maybe question 5. We'll take a look at working out maybe what the cosine of 5 pi on 3 is. So again, I know what pi on 3 is. I can work that out because I know that pi is 180 degrees. So pi over 3, I need to break that up into 3 equal pieces. So I'm looking at 60 degrees here. Now, how many of those portions do I have? I have 5 of them. So this is the same as the cosine of 300 degrees. Okay, I need 5 of these 60 degree portions. Now, the cosine of 300 degrees is the same as the cosine of 60 degrees, which is just equal to a half. And finally, one question where we've actually got to solve a bit of a trigonometric equation. Okay, so question 6, so just another one to have a go at where we're looking in radians now. We need to solve when, and we're solving for x here, when the cosine of x squared, okay, so this cos squared of x is equal to a quarter. And we're looking across this domain from 0 greater than or equal to x greater than or equal to 2 pi. So if we're going from 0 to 2 pi, we're just looking at our standard unit circle, just one trip around the unit circle. So what if I take the square root of both sides? Well, then I see that the cosine of x can be equal to plus or minus the square root of a quarter. Okay, so I can rewrite that as plus or minus the square root of 1 over the square root of 4. And the square root of 1 is just 1. The square root of 4 is just 2. So I'm looking at plus or minus a half. So when is the cosine of x equal to plus or minus a half? Well, we can first work out when is it equal to positive a half. So when's it equal to plus a half? When's it equal to minus a half? It's going to be equal to positive a half. We know if we're thinking about degrees, this happens at 60 degrees. Now, what is 60 degrees in terms of pies? Well, pi is 180 degrees. So to get down to 60 degrees, I'm going to need to break that up into 3 pieces. So pi over 3 would be 60 degrees. So I'm looking at pi over 3 here. So 60 degrees being pi on 3. The other angle that's going to give me positive a half would be my 300 degree angle. Now, how many of those pi on 3 portions do I need to get to 300? Well, I'm going to need 5 of those pi on 3 portions to get to 300. So the other solution would be 5 lots of those pi on 3s, 5 lots of that 60 degrees. If I wanted negative a half, I'm going to need to look on the other side of my unit circle, and I'd be looking at maybe 120 degrees and 240 degrees. So on the unit circle here, we've got our 60 degree angle, our 300 degree angle, both coming to a half on the x-axis, and now this time we're looking at coming out the other way, and it's these 2 angles here, so 120 degrees and 240 degrees. Now, how many of these pi on 3 portions do I need to get to 120 degrees? Well, I need 2 of them. So I'm going to get 2 pi on 3s. And again, a pi on 3 portion is equal to 60 degrees. So how many of them do I need to get to 240 degrees? I'm going to need 4 of them. So the other solution would be 4 pi on 3. So I get these 4 solutions in radians to tackling this sort of problem. So hopefully that makes some sense about how we can tackle these sorts of exact value problems and these trigonometric equation problems using radians. And it's no different to degrees. We've just got to be confident swapping between our radians and our degrees.